Now, let's take a look at our OpenStack compute environment, which is codenamed Nova. Before we get any further, I want to give you a quick tip about OpenStack and the Nova environment. Recall that OpenStack itself is a cloud ecosystem, but it does require a hypervisor for the compute platform. Nova itself is not a hypervisor. In fact, Nova is the control plane or the management layer for an underlying hypervisor. I get asked all the time, hey, how do I replace my VMware vSphere environment with OpenStack? Or how do I replace my Microsoft server environment with OpenStack? This is just not the case. It's not an apples to apples comparison. You're still going to require a hypervisor underneath, and that very well may be a Microsoft or VMware environment. At any rate, let's move on. Our OpenStack compute service is a platform on which we're going to run our guest machines. A little bit of terminology you're going to find is that we refer to booting instances, and our instances are booted from our glance images. So you recall that Jens loaded those standalone images there, and Clara had our custom images for WordPress in our MyCycling Store environment. This is what we're going to do, is we actually boot a running instance based on that base machine that was a glance image. Underneath that, there's hypervisors that have to run these compute platforms. There's multi-hypervisor support already in an OpenStack environment. So you can run a number of different hypervisors if you so desired, or you can run any one of these particular hypervisors. You can run KVM, Xen, VMware's vSphere, or Microsoft's Hyper-V. In fact, there's actually more hypervisors that are supported, and if you go to the OpenStack and wiki, and you can take a look at the Nova support and different hypervisors and different feature sets that are supported within Nova. But these are typically the top four that we're going to talk about, mostly because KVM and Xen are commonly used open source platforms, and then on the commercial side, most people are typically running a VMware vSphere or Hyper-V environment. Again, it's not that everybody is, but these are just very common. One of the limitations, so to speak, is that you require a separate Nova instance for each hypervisor. This is not a problem because they typically are a one-to-one. You're using one control layer for one underlying actual data layer at the hypervisor. If you run multiple hypervisors, it's particularly important that you have to use a different Nova instance because each has its own different instruction set based on the underlying hypervisor driver. So again, Nova is our management platform for the underlying hypervisor. It's very important to understand that terminology. Next up, we're going to talk about regions, aggregates, and availability zones. Regions are actual logical pools of OpenStack services. There's really no specific tie physically to what a region is, but logically it has to contain all of the different services in order to operate an OpenStack environment within each region. Then there are aggregates. Aggregates are groups or pools of OpenStack endpoints that are based on physical characteristics. You can assign any characteristic to it, but typical ones we would see would be an SSD-backed pool of hardware, or fast networking environments such as 10 gig NICs or perhaps 40 gigs. If you have 12 core processors versus 6 core processors, you could group all of your 12 core processors into an aggregate pool. And then lastly, we have availability zones. Typically, an availability zone is used to describe a physical region where a number of OpenStack endpoints are located. So we could call it Toronto, or we could call it Chicago, or we could call it Alaska, or London. There's any way we could describe it, but again, typically what we're seeing is that they could be US Northeast or European Union Central. They're described to be able to create regionally located availability zones. And that's where the confusion comes in sometimes, because We talk about availability zones and regions, but we mean physical regions. Let's take a look at what it actually looks like in a graphical way. Our first environment that we have is our keystone environment, which is our identity and authorization in platform. Then we have a horizon environment, which we're going to talk about later on, which is our dashboard environment. This is the web front end that we use to be able to access our OpenStack environment. Inside our keystone environment, we're going to create these logical regions. I couldn't think of a good name, so I just call mine Region 1 and Region 2. Seemed like a good idea at the time. Inside each of our regions, we provision endpoints to provide services into those regions. So you'll notice at this point we have similar services in each region. So we have specific endpoints that are allocated to be able to provide services into these logical regions. Inside those regions, we also have our availability zones. These availability zones, again, I could call them Chicago or Hawaii or whatever I so desired, but I'm just going to go with the generic term and call it Availability Zone 1 and Zone 2. Inside all of our availability zones, I've deployed our Nova endpoints. So all of our compute platforms are running and then allocated into our availability zones. So you can see the logical layout. It makes a lot more sense when you actually physically lay it out in kind of a graphical format. But then don't forget, we also have our aggregates. Aggregates aren't limited to physical locations. So we can create an aggregate pool of Nova endpoints based on physical characteristics. Let's just say we wanted to create an aggregate for everything that has a 10 gig NIC versus a 1 gig NIC. And we wanted to create an SSD-backed pool for our fast I/O machines. It's just easy to do. And then lastly, we could create an aggregate pool based on our traditional SATA environment. You'll notice that some Nova endpoints can be in multiple aggregate pools. That's because they may have more than one physical characteristic that we're assigning to a logical aggregate pool. Again, this is not a physical characteristic in that it has to be a physical location, but it's a descriptive about each Nova endpoint. Hopefully that all makes sense.